So welcome back to my channel. So today we are going to discuss about what kind of technology leads to spin-off or what kind of technology, whether a certain technology is better to be licensed from the university, or it is a good option to go form a spin-off out of it. So what we are a community of researchers working in academic environment, and we want to uh, plan our bigger or our research planning. Bigger planning of the research is such that after 5 or 10 years of work, or maybe 15 years of work, or maybe more or maybe less, we want to see something forming. We don't want to uh, wander around aimlessly. So apart from papers, of course, that is important, but if something comes up important, very interesting, and if we can see that it has a potential commercial value, then in generally we go for patent and all this thing. Now after patent, what is next? So there is mainly two options. I think in India at least there is two options. One is that that patent will be there, and if certain company is interested, then they will apply for licensing it, and from there the university will get money, and the inventor will also get some amount of percentage of money. So that is good for our future goal, because that will bring money to the lab and university, and that will be good for the future funding and all this thing. But there are some cases where the particular work that we do, like 5 or 10 years of research, and that leads to some sort of technology, not in a big sense, but in a focused sense, something new, interesting, that are more suitable for forming a spin-off rather than licensing it. And we will discuss about this thing today, that what are the differences, like the final output of the research, the technology that we produced or invented, what characteristics in that technology we'll see, and we'll decide upon whether it is suitable for licensing, and in that case we just patent it and let it be as it is, or we will find maybe some interesting characteristics in it, and then we will decide to do spin-off out of it, or make a spin-off out of it. If not us, but then we can always approach other people, or people in the university, and all various other peoples. So we'll discuss this thing, we'll understand this thing today in today's video. Now these are the main differences, like I divided in two parts. Like, so for example, you've done research for 5 or 10 years or maybe more, and the kind of there is interesting invention you feel like, and then you need to see that your particular invention or the patent that you are applying for, whether it contain these values or not, and depending on that you can decide it is good for licensing or it is good for making a spin-off out of it. So first thing is that technology has to be radical, then only you can do spin-off out of it. And if it is not radical, rather it is incremental, then better to have a license out of it. That means other company or established company will license your patent, or your invention from the university. So yeah, other aspect or other characteristics is if it is a tacit invention rather than codified, then it is good for spin-off. If it is codified, then it is good for licensing. If it is early stage, then spin-off. Late stage, licensing. General purpose, then spin-off. But if it is specific purpose, then licensing. Then from a customer value point of view, whether it is a adding significantly to that technology, your technology is adding significant value to the customer or not, then it is spin-off. Then if it is moderate, then it is licensing. Customer means it can be end users or various things. And then other is like whether it is a major technical advance. If it is, then it's good for spin-off. If it's not a major technological advance, rather it is a process invention, small invention or incremental invention, then it's better to remain it, or better to keep it as a patent and hope for someone will take it as a license it, for their particular work in the company, or new product in the company. Finally, strong IP protection. Spin-off needs strong IP protection in terms of like, what are the potential product out of it. So depending on that, you need to write your patent in a very strong way. Then only it is in future run you will be able to make a spin-off out of it without getting into the legal trouble and all this thing. Whereas weak IP protection in generally means that it is better to make it a license for the other established companies. So now we'll go into discussing every aspect of it in detail, and I hope, and most of these characteristics are more or less close to each other. They are converging or have some relation to each other. So anyways, we will discuss these things one by one. Now we will discuss what we mean by radical technology and why radical technologies are more better to be it is better to form a spin-off out of it rather than licensing it. So most university inventions are not appropriate for founding a spin-off because they are single product extensions that are too incremental to justify the creation of a company. Consequently, they would better complement a business unit within an existing company, because existing companies already know how to exploit inventions in a particular market or technical field, and so would have an advantage over a new firm in the exploitation of an existing technology. A process invention that improves an existing way of doing things doesn't work well for starting a company. You need more than a tweak of an existing process. You need fundamentally new process, a radical process. In particular, they talked about having technologies that represent products or services in particular, they talked about having technologies that represent transitions in marketplace or that generate revolutions in the way that products or services are created. For example, the founder of one of the semiconductor spin-off explains that you have to write transitions. As a startup, you don't have the same resources as an established company, so you have to take advantage of the transitions in the market. So I'm reading from the article from which I'm creating this video, because I feel like these passages are way more important. So rather than explaining thing in my own words, I will read it some portion which are very interesting. Now there is a way to explain why radical technologies are better to be a spin-off rather than as a license in some existing established company. Because first reason is radical technologies cannibalize existing asset, and that's why existing established firms or companies, they don't appreciate that, because that will disrupt their own business, because they have to undermine the already well-oiled machinery which is producing money for them, and they have to undermine that and invest into further R&D and all this thing. So there is a very good reason. Let be patient and let's listen to this. Second is radical technologies undermine existing organizational competencies. Third is established firms tend to react to a radical technology with disbelief. Now this looks like a little bit weird, disbelief and all this thing, but this will be clear in next few minutes, I guess, because when you have a big corporation and it is going well, so when you have a certain thing going well, then there is always a resistance in the organizational structure to new changes, which has the potential to disrupt the present the profit making process. So that will always be there, and that's why radical technology, whatever, because by definition it has this good chance of disrupting business, even the business of the own company who is researching on those new radical technology, making product and all this thing. So the established firm with a dominant market position in an industry rarely adopt radical innovations, because those innovations would cannibalize the sales of their existing product or services. So that is what it really means. I think this is very much clear, because organizational competencies and skills are expensive and difficult to create. Established firms do not want to change them. Hence, they do not like to exploit technologies that are based on new technical competencies and skills and seed radical technologies to independent entrepreneurs. For example, the reason is like, in generally any kind of invention, it is not a wholesome that there will be no patent which talks about zero to last every bit of detail of the product. Always, even if it is a very innovative one, it will talk about some innovation in certain processing chain, certain part of the processing chain. Now when you are trying to incorporate that new invention, whether it is good, whether it will work or not, so that's a different ball game and will be decided in future. But you have to incorporate that into the value chain or the processing chain, and then by default you have to think about all your processing chain, whether those are optimized or not, or whether, and hence it needs a lot of investment, a lot of talent and a lot of R&D. So it's not just about that particular patent, it's more about, in a big corporation, they have the manufacturing and they have the whole machinery, and so when they bring or when they want to change a certain part of their manufacturing process, they have to think about all the full processing chain, even the raw material that they are buying from or sourcing from other companies or other reasons, let's say. So they need to think about all those processes, and there is always an uncertainty, and unless the company or the corporation is in a danger, they have to make these changes and all these things, otherwise they will die because they have some loan or etc etc. If they are going well or they are making profit yearly, then this changes, this decision of having a whole thing changed, and mind you, these are all very expensive actually. And one of the difference between doing research in a university lab and in a industrial lab is that in an industrial setting, those people have to think about all the processes, so from their perspective things are not that obvious as maybe from a professor's perspective working in a university lab, that this is my tabletop experiment I'm doing and this is what the result shows, and that means it implies that these will be the changes in future and also this is not straightforward in an industrial setup, because there are a lot of invention that happen, but eventually the final product that made by, let's say, some big corporation, big companies, they may not incorporate all of it. There will always be a cost benefit analysis, and those cost also comes from shuffling all the way of doing things and deciding a new way of doing things. So it's very complex. When technologies are radical, they also impose changes on the composition of products. These changes undermine the competence of existing firms because they require firm to change the materials used and methods employed to create products. As a result, established firms seed radical technologies that change the composition of the product to spin-off firms. Now, other thing is like, so there is another interesting thing that they had mentioned, and I think this analogy is very interesting. That think about people in the big corporation as those religious people who had this great great belief on the way of what they are doing, and that is some sort of a religion. You can think about, and we know that religion. If you ask someone whether you want to change your religion or not, it is always a difficult decision because there are a lot of question, family and etc. So the big corporation, the managers, and even the R&D engineers, scientists, they are in that so much complicated. They are inside that so much complicated process that whole thing forms some sort of religion. It's not in the negative sense, but this is a good analogy. And just like you are not, it is not easy to change someone's religion. From a point of view of if you are want them to change, that's also difficult. And from the point of view of the person who you want to change the religion, from their point of view also it is difficult. From both point of view it is difficult. So you can understand this analogy and why this is very difficult, and that's why it's better to form a new company, because in a new company they don't have the prejudices that these are the way of doing what we are doing, and we don't want to change everything. So in a new company they have to do it everything from the scratch. So depending on that, if they think that their particular invention is very groundbreaking, then they can think about whole processing chain again, and they can get the funding from the various places. They can convince them, and then we have a whole set of value addition chain, and that will be, and in the end the end product will be something which can be market wise very competitive with the existing product. That can happen, or it can be other way around, that it is not competitive at all. This is all the time happen, even if the invention is very interesting, but the whole processing, the small value addition chain has to be placed in right way, so that the price tags are competitive with the similar product in the market. The major firm were looking for something that would have a direct fit into their existing product line, or that would give them incremental sales with relatively little investment and time. So that is more or less is the aim, and that's why they look for licenses of that sort, or patent of that sort which can be licensed. Another aspect is disbelief. Although from an outsider point of view it may seem little bit odd, because in the end those are technologists, scientists, engineers, management people. They do their job on the basis of pure logic. That's what at least you may or we may think of, but then things are way more complex, and in most of the cases the decision making process can have a lot of flaw, in a sense that one of the origin of flaw is disbelief. And I think I can talk about this thing and you will understand this thing. So I will read it from here. In general, established companies reject the value of radical technologies because they operate in a particular technical paradigm that other engineers and scientists come to believe is the right way for particular technology to operate. This paradigm leads researchers to believe that one must focus on certain designs, materials, composition, and so on in a particular technical area. Those developing the technology from within this paradigm rejects effort that do not work within the existing paradigm as wrong. So I think we can understand here that I don't want to disrespect anyone, but then people working in big corporation, we know that it's a huge group of people, and some group are in the, let's say, if in case of biomedical imaging device, it can be some group maybe from in the imaging department, or not department but imaging group. Some will be material science group, some will be electronic engineer, some will be computer scientist, some will be technical person. So all these different groups, and they and of course in the hierarchy we have the maybe some CEO or maybe some lower I don't know, means maybe some manager, doing managing tasks, which is equally important. Now the problem or this is at least the best thing we have, that's the way it will work. But from an individual point of view, if I am a person working in an imaging science group, I have some understanding about the people in the material science group, what they are doing, what their vision is, on all this thing. But in the end, it's so complex that we have we kind of believe that this is the way of doing thing, that oh yeah, this material will give this much improvement or this much resolution, whatever it is. And so since it is very complex, there will be certain amount of belief that we developed on, and that will lead to certain prejudices, which I will not say it's, maybe prejudices is a bad word, but at least rigidity of things, which is normal thing to happen in big industrial R&D sector. But on contrary to people doing research in universities, they are in the more of a frontline, and not in the, frontline doesn't mean that these people are doing more important thing than those people. Those are also important because they are making the product, which is not possible unless you solve all this complexity. But one of the advantage of doing research in universities is that you focus on the certain very focused research actually, and there was a chance that you make the you come up with something new, groundbreaking, even if those are from outsider or from an industrial point of view, it's not that believable. So this belief thing is, I think, very much true, although from an first if I tell you, it may like little bit odd, but I think it is true. So that's all about the radical technology part. So we understand that why radical technologies, which are defined by certain characteristics which we understood here, they are better to be it is better to form a new company and work on it rather than licensing it, because licensing will not happen. You may have great patent out of it, but nobody will be interested, and 20 years will be gone. You will see no people are interested in patenting it. So in that case, you have to take that lead, and if you are very courageous, you may leave your academic environment and go to form a company and all this thing, which will be very interesting uh, job and very challenging, I will say, and very dangerous, I will say. But it is something very worth enough if you believe in your research, 10 or 15 year of research. Another characteristics of invention is whether the invention is a tacit form of invention or whether it is a codified and it can be written in patent in a very descriptive way, and so that other people from various companies, they can understand it and they can understand how this particular technology or the knowledge in the patent can be used to improve the product or creating a new product in the company. So those are more of a codified form of knowledge, but sometimes the invention can be more tacit. So it is so as I said that these distinction about invention, about your patent or whatever you want to say, are more or less not really separate of each other, like radical technology that we discussed in previous slide. Those are also related to that, but this is something that I want to talk about it in a different way. So let's say you worked on a problem, and I guess many of us don't really focus on, just after 5 and 10 years we should be have this. In a lot of cases the research is not really, means it is unpredictable. We can't predict with 100% accuracy that this will be happening after 5 years. We will be seeing this thing, we will be finding these things. Many of the cases it is not the case, and in fact that is this is counterintuitive, because the reason why we are doing research, because we don't know something, so we want to know that, and by the and in that particular journey we are more or less or there is a degree of uncertainty. We don't know where it will lead to. So but then there is always a certainty, depending on the whether we are able to plan it in a proper way, whether we made a good amount of preparation to start with. Depending on that, it is a good chance that we will stumble upon something interesting, and more and among those cases there will be certain case where we'll see that, okay, so this body of knowledge or whatever you want to say, this can be part of a patent, not just a paper. Now here in this case, patent can be tacit form of knowledge. By tacit, what we mean is that that you described your invention or certain idea sometimes in a more of a broad sense in the patent, but it is not really clear how that certain invention or certain idea will make change in the current state of our technology, whatever used in the industrial setup. So in that sense it is tacit, and many cases a lot of invention are tacit. The reason for that, I believe, is because in lot of technological areas we sort of the state of art industrial systems or products are very complex. Now certain innovation, the knowledge of innovation that is codified in mentioned in the patent, that is describing something in a very micro detail, and there is always a question that how that will impact the current state of art system and all this thing. And so, and also we discussed that there is in the previous slide also that there will always be some sort of negativity from the state of art people, or it's not people, I mean state of art community, who are doing the industrial work, commercializing things. Now from an inventor point of view, since this is a tacit knowledge, so he or she knows the idea in a very better way, and he and she can visualize it, how this can impact the future, or how it can disrupt the current state of our technology. So, but the point is, even if you try to, with best of your intention, you try to explain it in patent on, and many cases if you try to explain it to your colleagues also, it is not that easy actually to make them believe, because of this very fact that a lot of cases the technology and the systems are very complex, and there are a lot of aspect in it, and you never know how various things will impact or interact with each other. A lot of software development, a lot of hardwares. So yeah, so in those cases, it is said by the author of this chapter that it is better for the inventor to do make a spin-off out of it and prove that the idea works, and there is a commercial scope of it. So in that case, it is better to be spin-off, because what happens is that this tacit form of knowledge, mentioned in the patent, most of the time those will not get licensed by any company. So in your case, if you think that that okay, so I really believe in my invention, but it is not easy for other companies from their point of view also to license it, because they are not in a situation to believe it in that sort of frame of mind, which as inventor you feel like that you are very confident that this will certainly work. Yeah, and sometimes it may not work, but it's up to you as a inventor to make a decision that whether you want to make a spin-off out of it. So for that, of course, there are a lot of set of exercises that you can do, FTO analysis, etc. You can do market analysis and all this thing. So there is a whole body of knowledge and materials is there online. You can use that, and you can make sure that or you can increase the you can decrease the rate of risk, or you can do the risk analysis, risk analysis not in the conventional sense but in the qualitative sense I'm talking about here. And you can make a more of a solid case for yourself, just to start with, to believe, make you believe yourself on the technology or the invention. And more importantly, it is true because it's get patented, but whether this can be commercialized in a way which will be beneficial for your university as well as for your time also, because you'll have to give a lot of time to it. So yeah, so in these cases it is better to have a spin-off and not wait for other company to license it, because that may not happen, and the patent may get there will be, in general, the patents are given the status for 20 years and may not really get any license so within that time. And I think the time and effort for the patent goes away and it is zero. So rather than waiting for someone, you can do it by yourself if you really believe in it. Another important factor to consider is that whether a certain invention or a certain set of invention or certain set of patents, these are indicating that in a direction which is means it is like an early stage of development or early stage inventions. So in that case, it is better to form a spin-off or a new company around it, and not wait for other company to license it, which may not happen. So many university inventions leads to the formation of spin-offs because they are early stage technology that are little more than proof of concept when the researcher discloses the invention of the University Technology Licensing Office. Research has shown that when a university technology is at a very early stage of development and so is unproven, it cannot be licensed easily to established firm. As a result, early stage inventions tend to lead to the formation of spin-offs. For example, pharmaceutical firms want to license new drugs and they don't really do any true drug development in their laboratory. On the other hand, university research sometimes are more related to basic research. So the point is, the pharmaceutical company doesn't want to invest in something straight out of basic research in academia, which is not just true for any pharmaceutical industry, but for various other industries also. Other factor is that since it is of early stage of invention, that's why the value of the technology is to some extent uncertain. In many cases, spin-off firms serve as a mechanism to bridge the development gap between university technology and private sector products and services. By further developing early stage technology, spin-offs prove the commercial benefit of these technologies, making them more valuable for established company to license. Consequently, spin-offs often sell out to established firms rather than competing with them after they have proved the value of the technology. So here we are getting some sort of different point of view altogether, that it is not all the time that when you are making a spin-off, it doesn't mean that it's throughout it will remain as a big or throughout it will remain as a company and it will in future it will become a big company. It doesn't have to be like that. You can sell it depending on the fact that the goal had already been reached, and beyond that, to scale up the business of the new company, that means the spin-off, it will have to go through a lot of hurdles and a lot of capital intensive adventures, which is better that a big company will take over this spin-off, and then they will do that same thing, the capital intensive thing, because they are in more of a suitable position in terms of capital as well as experience. And the university of course will make money, but the point is, if we wait for licensing, it may not happen altogether. That's the point. Other fact is that various established companies, they are more focused on the existing operations and optimizing that existing operation. Even to a research intensive companies which could do further development work on university inventions, it is difficult for universities to license early stage technology successfully. In research intensive companies, the problem is that the managers often reject early stage university technologies because the adoption of those technologies would undermine existing research activities within the established organization. So there were a lot of structural problems. I will not say that everything is very negative about it, but then there is always a problem, not a problem, I will say conditioning in different setup. Like in academia, there is a certain kind of conditioning, and in industry, there is a certain kind of conditioning. By conditioning, what I mean is, in industry, there is a competitive and very competitive pressure on certain thing should work and certain thing produce certain value in terms of product or services, and it will immediately go to the market and provide good results. Not immediately, but I think if it is a big corporation, then it can really do a lot of thing. But in the end, they have to, or their managers have to show the balance sheet and all this thing. But in academia, that's the whole reason of academia, is that we can do a lot of things which may not be profitable in near future, but in long future it will be profitable. So although I'm not saying that everything is good in academia, in the pursuit of things, everything has to be for in the pursuit of knowledge for knowledge, that philosophy. Sometimes we also do something which are not really fruitful, even from a knowledge point of view. So in both work culture, I'll say there is a drawback, there is an advantage. So as a academic scientist, we have to understand that and appreciate that, because then we can position ourselves into better way. Another thing that the author talked about is, which I'm not really sure about, that they say that in addition, large corporations often find it difficult to assign talented people to the development of new technology. People with cutting edge product development skills often prefer to work for startup companies where they have the opportunity to make large sums of money through equity ownership. I don't know how much this is true in India, but they at least the author is saying that. So maybe in some context it is true. Other thing is that communicating information about the technologies, like since it is the early stage of development, even if a company license it, so always the question is that when the company and their R&D sector will do the development or the further research into that technology, so there are various technical information which may not be available in the patent but will be needed, and there the researchers, or the inventor of the patent or inventor of the early stage technology comes into the picture, and it is not easy for them to collaborate, and sometimes lot of licensing, they do have clause like they want to work with the inventor, certain time period of inventor they want, so I know certain things. So so there were certain way to tackle that also, but more or less this is another reason why early stage developed technologies are not good for licensing. Moreover, even if the buyer and the seller can agree on what idea they are contracting over, establishing a price for that idea is a problem, because ideas are intangible. It is hard for buyers and sellers to agree on what they can and cannot do. This agreement, of course, makes it hard to establish a price for the ideas. As a result, the buyer and seller cannot consummate a transaction. So this is also a problem. Like sometimes if it is early stage technology, then the price that the company is offering, which may find it to you as an inventor, or your TTO, means University Technology Transfer Office people, they may find it to be disrespecting, and that is a natural phenomena, because there was a lack of results, because it is more of a proof of concept thing. So in that case, it's better to work more on it, and that can happen even in your university lab environment, or maybe in a spin-off environment. And then of course, after you had proven it that this technology works, then you can ask much of a better respectable price, and they means the company will be more happy to pay it. So that's the point here. Another characteristic of invention is to look for is whether it is a very broad scope invention. That means whether it is a general purpose technology or not. If it is a general purpose or some sort of a general purpose technology, then there is a good reason that one should form a spin-off or new company, that rather than waiting for other company to license it. So university spin-offs also tend to exploit general purpose technologies or basic inventions with broad application in many fields of use. A good example of general purpose technology that led to an MIT spin-off is a piezoelectric device. The technology combines piezoelectric material with active control systems to remove vibrations. Among the applications to which this technology has been put for electric shocks on airplane wings, bicycles, skis, baseball bats, automobiles, and medical devices. In the biomedical area, tissue engineering technology provides another example of a general purpose technology because it can be used for development of variety of different products. General purpose technology tend to be exploited by spin-off companies for two reasons. First, they offer multiple market applications. Second, established companies have trouble identifying what to do with the general purpose technologies. General purpose technologies or platform technologies, as practitioners often call them, provide a good basis for starting a spin-off company because they allow founder to change market application if the first application that they pursue turns out to be dead end. This flexibility is important to the survival of new companies which has no existing products to fall back on should an application for a new technology prove to be unviable. The possession of a general purpose technology facilitates the financing of university spin-offs because it increases the likelihood that the spin-off will identify a valuable market application for the technology. As a result, investors favor university spin-offs that exploit general purpose technologies. For example, one of the venture capitalists that invested in an MIT biotechnology spin-off explained that he had evaluated several MIT technologies but was interested in one company's technology because if you had an immunomodulator in a carbohydrate, you might have a whole line of products. So I think these are examples, and I'm reading from the text itself, from the passage, so you can see what it means. The very advantage, on the other hand, the very advantage of flexibility and diversification that general purpose technologies provide to spin-offs create platform for established companies. This seeming paradox occurs because new firms look for the best technology for starting a company regardless of the industry or stage of the value chain at which that technology can be applied. In contrast, established companies look for the best technology to support the further development of the products and services they already make in an industry in which they already operate. Because general purpose technologies can be applied in a variety of different markets and at a number of different stages of the value chain, they tend to be difficult for established firms to evaluate and exploit. So similar thing like radical technology, etc., there is a same structural problem. I will not say structural, it's not a problem, but it's a state of things with big corporations, and maybe in particular this book may have exaggerated things to some extent, I just feel like, because maybe there are companies, especially the bigger corporation, they have lot of thing going on which may not produce the fruits in near future but in long future, so that can happen. And also I feel like there will be a lot of companies which are in a verge of collapse and they have to change their way of business and technology and etc. So they have to reinvent and pivot from the trajectory that they are going through. So there also innovation happens. So it's not just like that everything goes from university and then the companies are basically doing some sort of R&D and then making sure that it fits into the marketplace and all. It's not that, I think. At least nowadays things are lot of big corporation and different companies, maybe things are different. So yeah. Another criteria of whether a certain set of invention is suitable for making a spin-off out of it is that the technology need to be cutting edge and not duplicate of previous technologies, because whoever the entrepreneur, or whoever will be making a company out of it, whether he is an inventor, whether he is an independent entrepreneur, he or she have to see a significant economic value out of it. Then only it is of uh, worth of taking risk, because from the point of view of the time of the entrepreneur, from the point of view of the investors, because they also want to see a good return, Now, another second, when the technology is far advanced technically relative to what established companies are doing at time, it is hard to license the technology to them. If the gap between technology that the established firm is currently using and the technology that the inventor has created is too great for managers in established firms to understand the new technology, the inventor cannot pursue them the value of changing technology. As a result, inventor have to found spin-offs as a way to commercialize the technology. Only through the creation of products and services can the inventor convince established firm that an invention that makes a major technical advance should be adopted. For example, the founder of one MIT mechanical device spin-off explains that he started a company when his effort to license them to established company failed because the patents were too far advanced from what the companies were doing at the time. What happened was that there was a fair amount of interest from the mechanical tool companies, but the inventions were really on the very end of performance at the time. They were too far ahead and the industry wasn't ready for it. There were a lot of nibbles but no takers. So yeah, so that is also another criteria. So I'm just reading from the passage from the chapters here. Yeah, that's it. Okay, so another characteristics of invention is or not just one invention, but let's just say series of invention. Doesn't have to be uh, related to one inventor, or doesn't have to be related to particular university itself. So it's here actually the context is not from the point of view that whether an inventor will form a spin-off company or not, but rather as an entrepreneur, what he or she have to decide upon when he is going for forming a company or spin-off and all this thing. So I'll just read it from the passage itself. When a new firm is founded, it does not have advantages based on superior manufacturing or marketing and distribution, which allows it to outcompete other firms. Thus, existence of strong intellectual property protection enables the founder of the spin-off to build the value chain for the new firms before competitors have copied its new technology. In general, spin-offs are more likely to be founded when a large portfolio of broad scope patents protect an invention. Spin-offs are more likely to be founded to exploit a technology if the invention yields several interlocking patents that build a wall of protection around it. Interlocking patents are important to spin-offs because they allow companies to control more of the technology necessary to exploit an invention. This characteristic is important because spin-offs have many disadvantages when competing with established firms in marketplace. Because patent portfolios are so important to establishment of university spin-offs, entrepreneurs interested in creating spin-off companies often shop around at several universities to create the right patent portfolio, that is a portfolio which is strong enough to justify the establishment of a spin-off. For example, the founder of one of the MIT biotechnology spin-offs explains that he established a strong portfolio of 30 patents families that include 19 patents on cell deaths from 8 universities so that he could found a firm. Spin-offs are also more common when patents are broad in scope, because broad scope patents allow a spin-off to block competitors from exploiting the same technology that they exploit, providing a stronger competitive advantage. The broader the scope of the patent, the more likely it will be that the competing products and services will infringe the patent, and more effective the intellectual property will be. Many of the founders of MIT spin-offs that I interviewed pointed out the importance of broad intellectual property protection in their decision to found a company to exploit the invention. For example, in case of one of the mechanical device spin-off, the founders explained that they decided to create a spin-off company once patent counsel told them that they would be able to obtain broad scope patent on their invention. Similarly, the founder of the biotechnology spin-off explained that she considered it worthwhile to found the company once her patent attorney indicated that patents on the technology would have broad claims and would not infringe other parties' patents. So here we understand that so it is not from the inventor's point of view, like an academic researcher's point of view, but more often broad scope. Let's say an entrepreneur who is interested in founding a company, or maybe the entrepreneur can be the inventor himself, and he had some crucial patent, but then to form a company he needs to shop around various other patents, not just in his own university but from other universities also. So in that cases he or she have to consider this thing, that whether it is the portfolio is powerful enough, because it is very true that as a starter you don't have that advantage compared to the well established company or firms. So you need that kind of a strong portfolio of patents, and it will be much good if it is a broad scope patent. Then broad scope patents are basically here. Broad scope patent here means you can think about in a way that patents are like claiming lands which are not unclaimed, and some cases after a lot of exploration you may find that certain avenues or certain lands are really unexplored and not discovered yet, and you claim the land in its totality. So maybe the example is not really politically correct and all this thing, but yeah, that's I think one of the example you can think of. So this is the reference. This is a book actually, and the video is made from the chapter 6 of the book. It is an old book, 2004 book, so as we should expect that lot of nuances that the author talked about, maybe some are gradually getting changed, especially about negative comments. Not negative in a sense, but negative comment about the industrial R&D setup. There are a lot of limitation in industrial setup and all these things, so which may be not true nowadays, at least. But I think the overall thing that he or she, the author, want to talk about is true, that there is a certain good or bad in doing research in university lab, and similarly good and bad in doing research in an industrial laboratory. In industrial laboratory you will get a lot of I think the funding will not be a problem, or or you'll get more exposed to more range of processes that is related to the development of the product itself, and you will be working with more of a bigger team, and you have to show them your work and they have a comment on it, and from that you have to change it, so which may not be the case in university where you are the only people working in your lab. And the works in university are more of a proof of concept, but at the same time those are at the forefront of knowledge, boundary of knowledge, that I will say, not from a fundamental science point of view but from the technological know-how point of view. And that's why a lot of interesting things are originated from university, but at the same time various process in reform means here process invention or process improvement. I mean, what I try to mean is that the optimization of a certain technology or certain product that really happens in industrial setup, and those optimization are equally important for the society. From a bigger point of view, it is equally important for the society, not just from the point of view of the company, because company have to compete with the other companies making a, let's say, cheaper or more better product, two end of things, two different dimension here. But it is good for the society also, because if we just rely on the university R&D, then what will happen is that there are a lot of things which may not see the daylight and will not be here in our present life, using various devices that we use. That there is underlying broad invention that happen in the university setup, but then lot of important innovation which are small innovation but equally important that happen more or less in the industry setup. So both are important, I will say, and both are fulfilling to each other, and as a academic researchers we have to appreciate this particular fact, and that will give us good chance of placing ourselves in the right position and making good decision about our research, like when to go for a spin-off, whether it is worthwhile or not. So yeah, so that's it all about the video, and if you like the video, please subscribe to the channel and share this video, and yeah, that's it. See you in the next week.